Welcome to this explainer. Today, we're going to discover how seemingly lifeless space rocks floating out in the void actually hold the absolute key to solving Earth's resource crises and, honestly, to expanding humanity into the cosmos. So, let's just dive right into it.
Here's our roadmap for today. We're going to start by properly meeting these space rocks, then uncover our solar system's origins, explore the impending asteroid gold rush, learn a bit about space gas stations, and finally, we'll break down exactly how to mine them.
Section 1. Meet the space rocks, asteroids, comets, and meteors.
Okay, so before we start building some wild sci-fi future, we really need to clear up the confusion about what exactly is floating around up there in the dark. And if you've ever mixed these up, don't worry, you definitely aren't alone. Asteroids are those rocky metallic chunks mostly just hanging out in the asteroid belt between Mars and Jupiter. Comets, on the other hand, they're more like icy, dirty snowballs packed with frozen water and gases. They come from way out in the distant Kuiper belt or Oort cloud, and they get those massive glowing tails when their ice starts melting near the sun. And meteors? Well, they're simply tiny pieces of space rock, sometimes debris that broke off from comets or asteroids, that burn up super brightly when they hit our atmosphere. You probably just know them as shooting stars.
And, some of these objects are absolutely staggering in scale. Take Ceres, for example. It sits right in the middle of the asteroid belt and is 295 miles around. That makes it so incredibly massive that scientists officially classified it as a dwarf planet, which puts it in the exact same category as Pluto. We've actually sent space probes like Dawn to completely orbit Ceres, and they revealed this heavily cratered, totally unique world that is so different from the smaller rocks zipping around it.
But you might be wondering, what happens when these rocks get a little too close for comfort? Well, most meteors just burn up in seconds, giving us that beautiful shooting star effect. But out of the millions that enter our atmosphere every single day, roughly 500 survive the intense heat to actually land on Earth's surface. Most of them splash into the ocean or land out in deserts or Antarctica. And when they do finally strike the ground, they're officially called meteorites. Over the years, scientists have actually collected over 10,000 of these cosmic souvenirs.
Section 2. Clues to our origins. Reading the ancient cosmic debris. Let's rewind the clock for a second. About 4.5 billion years ago, a massive cloud of gas and dust called the solar nebula collapsed. It formed our sun and the planets, but all the leftover debris, that became the asteroids and comets we see today. And why does this matter to us? Well, scientists believe that when Earth was young and totally lifeless, kind of like Venus, it went through a constant bombardment from these very asteroids. They literally crashed into our planet, delivering the water ice and complex organic molecules like carbon that filled our oceans. Basically, we likely owe our very existence to these cosmic delivery trucks. And today, robotic missions are going back out to visit them, reading this ancient history to prep us for the next great leap in exploration.
All right, Section 3. The asteroid gold rush. Trillions in the sky.
So asteroids aren't just artifacts of our deep past, they are literal gold mines waiting to power human civilization. Think about the device you're using to watch this explainer right now. It's built with rare earth materials with complex names like terbium, neodymium, or tantalum. Getting that stuff out of the ground down here on Earth is a notoriously ugly process. It destroys landscapes, relies on highly dangerous chemicals like cyanide and sulfuric acid, and it really harms local biodiversity. But out in space, it offers a perfectly clean, victimless alternative. We can extract what we need without harming anyone or polluting a single drop of Earth water.
And the scale of this wealth? It's honestly hard to even wrap your head around. If we could easily extract the resources just from the rocks sitting in the asteroid belt between Mars and Jupiter, the payout would be massive enough to hand $100 billion to every single person on Earth. Let that sink in. $100 billion per person. That is the literal definition of infinite abundance.
Inside these rocks, we're looking for absolutely critical industrial and precious resources. We're talking iron, nickel, platinum, gold, phosphorus, zinc, basically everything our planet is slowly running out of. To put that into perspective, a single massive asteroid known as 16 Psyche contains enough iron and nickel to cover the entire world's metal needs for millions of years. Millions! It's absolutely staggering.
But wait, if they're so incredibly valuable, why aren't we out there mining them right now? Well, here's the catch. Right now, asteroid mining is exactly like filtering the ocean for gold. Sure, there's over 20 million tons of gold dissolved in seawater, but it costs way more to filter it than the gold is actually worth. Going to space is just incredibly expensive. It's simply too costly to send traditional, heavy, fuel-guzzling rockets into deep space just to haul a bunch of metals back down to Earth.
trillions spent to get there makes billions in resources basically worthless.
Section 4. Building Space Gas Stations. The Cosmic Stepping Stone.
This brings us to a huge, mind-bending shift in perspective. What if the real value is not in bringing the resources back down to Earth, but leaving them exactly where they are? See, we're trapped in Earth's massive gravity well. It actually takes more energy to escape the first 300 kilometers of Earth's gravity than it does to travel the next 300 million kilometers through the vacuum of space. It's wildly inefficient to burn massive amounts of rocket fuel just to lift heavy building materials and water out of our atmosphere.
So instead of dragging all our survival needs all the way from Earth, we can just mine near-Earth asteroids for water ice. And water in space is everything. It allows astronauts to maintain good hygiene, you can use it to grow food in zero gravity, you can literally split it to produce breathable oxygen, and, most importantly, you can refine those water molecules directly into high-efficiency rocket propellant.
There's this quote that I absolutely love. In a way, asteroids would be our space gas stations. Think about taking a road trip across the country, but there are absolutely no gas stations anywhere on the route. You'd have to tow a giant, insanely heavy tank of gas behind you the entire way. That is exactly how we do space travel today. But by using asteroids as refueling depots, we'd have the power to effortlessly explore Mars, Europa, and way beyond. We could also use asteroid iron to construct massive, low-cost spacecraft components right there in orbit, completely bypassing that Earth gravity penalty.
Section 5. How to Mine Asteroids. A step-by-step guide.
Okay, so how do we actually pull off this science fiction engineering feat in real life? Let's break it down. The very first step to making it affordable is completely rethinking our spaceships. Instead of those massive chemical rockets we're used to, we'd use highly efficient electric spaceships to visit near-Earth asteroids. Now, while they aren't powerful enough to launch off Earth, once they're already up in space, they sip a remarkably tiny amount of fuel to travel vast distances. This drastically cuts down the initial launch weight and really starts to make the whole mission financially viable.
Here's the actual step-by-step game plan. Step 1. You arrive at the asteroid and fire lasers to vaporize some of the material, which acts as a thruster to stop the rock from spinning. Step 2. You use precise orbital mechanics to gently nudge the asteroid, pushing it all the way into the moon's gravity for a super stable, easy-to-reach orbit. Step 3. We process the rock. Now, we aren't sending up astronauts with pickaxes. Instead, we use giant mirrors to focus sunlight to literally boil out the gases, and then we use centrifuges to separate the heavy, dense metals. And finally, Step 4. If we do want to bring that precious cargo back to Earth, we 3D print heat-shielded gas bubbles right there in space, fill them with our platinum or gold, and safely drop them straight into Earth's oceans to be scooped up by waiting ships. The sheer efficiency of space rocks is just astonishing. I mean, even extracting a tiny 0.01% of an asteroid's mass in precious metals yields vastly more than the equivalent amount of ore processed down here on Earth. The concentration of wealth is staggering. It means that as this space infrastructure grows, we could eventually shut down terrestrial mining entirely. We can let our ravaged landscapes heal, making toxic earthly mining an anachronistic, weird thing of the past. It'd be kind of like having an open campfire right in the middle of your living room.
But before we launch headfirst into this incredible, clean, and abundant future, we have to pause and ask a very serious question. If one nation or a single corporation wins this gold rush, if they figure out the tech first and just monopolize these infinite resources, what happens to the global economy? Will we see a future of shared human prosperity or an unimaginable concentration of power and wealth? As we look up at those tiny points of light in the night sky, we really have to ask ourselves, who truly owns the cosmos? Thank you so much for joining me on this explainer, and I will leave you to ponder that one. Keep looking up, and I'll catch you next time.